All right, lesson 7. We're going to factor some special polynomials. So we're going to see some shortcuts, just like we saw some shortcuts when we were doing the multiplying. We're going to use those same shortcuts, but now we're going to go in reverse. Okay, we're going to go backwards and factor. So if we factor the polynomials just like we did with lesson 6, okay, multiply a times c and find factors of 16 that add to give you 8. Okay, well 4 times 4 is 16, and then if you add 4 and 4, that's 8. So you have x plus 4 and x plus 4. Okay? Next one. Okay, a times c, you end up with 36, so you need factors of 36. That will add to give you negative 12. So they're both going to have to be negative because the middle is negative, but c is positive, so both will have to be negative. And that'd be 6 and 6. So we're going to break this into, negative 6 and negative 6. Okay. And then I find the GCF of each. So I find the GCF here. GCF of 4n squared and 6n is going to be 2n. So then I take the 2n out. So I have 2n. And then what would be left? Well, it would be 2n minus 3. Okay. And then factor out here as well. Oops. Negative 6n. So factor out here. And what I need to factor out is going to be a negative, so that the 3 is negative, and I'm going to factor out a negative 3. And we have 2n minus 3. So now the outsides and the insides are my two binomials. We have 2n minus 3 and 2n minus 3. Okay, so what pattern do you notice? Well, both binomials are exactly the same in both problems. Okay, so we've seen this before. It's just that we went the other way. We started with the exact same and then multiplied to get the trinomial. Okay, so what we're looking at here is this pattern where we have perfect square trinomials. Okay, where A is a perfect square and B is a perfect square. So if you look at this first example, a squared is perfect, 16 is perfect. You find the square root of both of those. Okay, so you get x and 4. And then you have to see, well, if I take 2 times x times 4, does that give me 8x? And yes, it does. 2x times 4 is 8x. So then that is our shortcut that we used earlier, okay, when we multiplied. Now we're just going back the other direction, and you just take the square root of each. So if you take a look at this first one, x squared plus 6x plus 9. Is A a perfect square, and is C a perfect square? It says A and B, but what A and B would be are the square roots of these. So the square root of x squared is x, and then the square root of 9 would be 3. So now, if I take 2, okay, this is step 2, is the middle term equal to 2ab? Okay, 2 times x is 2x times 3 is 6x. Does that give us our b term? Absolutely it does. So it's 6x. So if it's yes, okay, then what we can factor into would be x plus 3 times x plus 3. Okay, now you can always check. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Add our like terms, so we get x squared plus 6x plus 9. And that's what we started with. Okay, so to write x plus 3 times x plus 3 as one binomial, you can write it as x plus 3 quantity squared. Okay? So that's one shortcut that we can use if we notice that the first term is perfect and the last term is perfect. Okay, so we look here. First term, is it perfect? And the last term, is it perfect? Well, 64t squared is perfect. The square root of that is 8t. And the square root of 81 is 9. Okay, so now we would have to take 2 times 8 is 16. 16 times 9, 144. Okay, so it's 144t. Okay? And then, because it's negative here, then we're going to say, oops, 8t minus 9 quantity squared. Okay? Same thing here. Is a perfect? Yes, it is. 6h is the square root, and the square root of 25 is 5. 2 times 12, or 2 times 6 is 12. 12 times 5 is 60. So that would give us 60h, which is our middle term. So it works. And then our first term here, 6h, and because it's addition, we add here, and then we say 6h plus 5 quantity squared. Okay? Then next, shortcut. Difference of two squares. Okay, so here we have a perfect square, and it's a difference because they're subtracting. Okay, so the square, when you have the difference of two squares, this one is really actually pretty easy. Okay, you're going to find the square root of the first term, which is x, square root of the last term, which is 4. You're going to have one binomial that's positive, one binomial that's negative. The reason we have to have a positive and a negative is because this 4x would have to cancel out that negative 4x there. That to give us the 0x here. Okay? So to factor the next one, you take the square root of the first term, which is 2y, and square root of 25 is 5. And then again, we have one that we add, one where we subtract. Okay? So it's the same thing for each term, but now instead of both of them being addition or both being subtraction, one is addition, one is subtraction. So again here, is it a difference? Yes. It's subtracting. A and B perfect squares? Yes. Z squared is perfect. 9 is perfect. Okay, so the square root of z squared is z. Square root of 9 is 3. So you have z plus 3. Oops, the plus sign's already there. And z minus 3 as your two binomials. Okay, is there a difference? Yep, it is. Okay, a perfect square, yes. The square root of it is b. B a perfect square, yes. 100 is perfect. The square root of that is 10. So we have b plus 10, b minus 10. Next one, the difference again because subtraction. 25d squared is perfect. The square root of that is 5d. And the square root of 64 is 8. So it's perfect. Okay, so we have 5d plus 8 and 5d minus 8. Okay, so it's easy to factor some of these certain polynomials if you can just recognize some perfect squares. Okay. Then the last one is before I started any of these, what I first should have checked for is if I can take a GCF out of it, the whole thing. Okay, so here, is it a difference? Yes, it is. But we need, before we answer step 2, we need to see if there's a GCF between both of those. Okay, so if I have 12t squared minus 48, okay, a GCF of that would be the highest number we can take out of 12 and 48 would be 12. Okay, and that leaves me with t squared minus 4. So now that I factor that 12 out, okay, is this perfect? And is the t squared perfect? And is the 4 perfect? Yes, it is. Is it still different? Yes, it is. So now I find the square root of t squared, which is t, and the square root of 4, which is 2. Okay, now our binomial, okay, is going to be t plus 2 and t minus 2. But remember we factored out that GCF at the beginning? Just like when we factored out GCF any other time, that still has to be out front. Okay, so it's 12 times the quantity of t plus 2 times the quantity of t minus 2. So always, always, always check to see if there's a GCF at the beginning. Okay, so always check for a GCF at the beginning. If we don't, to possibly end up getting it wrong or simplifying the problem wrong. Okay, so always check for that GCF at the beginning. That's it. Remember, write down any questions that you have. We can talk more about this tomorrow. Have a good night.